In this video, we'll talk about dimensional analysis. When we're talking about dimensional analysis, we're usually talking about unit conversions. So we'll talk about it when we're talking about converting just, say, kilograms to grams and vice versa. And we'll also talk about converting rates. So miles per hour, feet per second, kilometers per hour, meters per second, that kind of thing. That adds a whole nother layer of difficulty to it. So probably the best way to start with these is just go with an example. So let's start with something that's a little on the simpler side. Let's just worry about converting units. So let's say I wanted to convert 3 yards into inches. Well, there's a little piece of information here that I'll have to pull from the ether. I know that 36 inches is equal to 1 yard, which is also equivalent to 3 feet. All of those things are true. So the useful bit is going to be right here. 1 yard is 36 inches. I have 3 of them, so I'm going to take 3 times 36. That should equal 3 yards. Which, if I take 3 times 36, I should get 108 inches. Now that one's pretty straightforward. When you're just converting units, it's pretty easy to tell when you multiply, when you divide, and just using what you know about the units can be very helpful. Let's take a look at a tougher example. Let's say I want to convert 75 miles per hour into feet per second. Now this one is pretty tough in that, what do I do? Do I multiply? Do I divide? How do I do this? And it can be a little difficult to determine what method to use. And it can be very difficult to figure out, okay, when do I multiply, when do I divide, what do I divide by, what do I multiply by? So engineers, physicists, mathematicians have come up with a method called dimensional analysis. And it's the idea of you treat the units kind of like you would a number, and you can cancel them out, and it can kind of help guide your thinking. So if we think about miles per hour here, what this really means is you went 75 miles in 1 hour, right? So this would be a way we can rate our speed as a ratio or a rate. So then we'll have some other useful pieces of information that are kind of useful to know. If we're looking at miles to feet, for example, well, I know that 1 mile is equal to 5,280 feet. And I can also say, if I think about it in terms of a ratio, 5,280 feet divided by 1 mile is 1. And I could say the same thing of the reciprocal of that rate. So 1 mile is 5,280 feet. Now the idea here is we want to convert our miles into feet. So I'm going to ultimately try and end up with something that has feet on the top and seconds on the bottom. That's what I want to get to. Now I'm going to have to multiply by some factors to make that adjustment. So the first thing I'm going to do is I'm going to multiply this by something. Just kind of like I do with common denominators. With fractions, I'm technically multiplying by 1. I'm not really altering it, I'm just changing its form a little bit. So the idea is I'm going to use one of these two ratios that I've got in blue here. And the idea is I want to use the one with the miles on the bottom, so that they'll cancel out with the miles on the top with our original red ratio. So what we're going to do is we're going to use this one, the first one we wrote. So I have 5,280 feet divided by 1 mile. And the idea is the miles will, in effect, cancel, leaving me just the feet on top. So this tells me I take 75 times 5,280 feet. Now this is going to get me to where I have feet per hour, which is closer to what I want, but I'm not quite done yet. So then I'm going to try and figure out, okay, the time piece, hours to seconds. And there's a couple ways you can go about this. So we know that 60 minutes is equivalent to 1 hour. And likewise, we know 60 seconds is equal to 1 minute. So we're technically going to have to do two ratios here. So we can write some useful ratios for ourselves. And I'll do that kind of below our work here, just so that we can see it. So 60 minutes divided by 1 hour is equal to 1, which is also equal to 1 hour divided by 60 minutes. Both these, numerator and denominator, on both of these fractions are the same. Therefore, it's 1, technically. So the idea is, I have hours on the bottom, so I want to use the ratio with hours on the top. There it is. So I'm going to multiply by 1 hour over 60 minutes. Okay, now I've got my hours to cancel. Now I have feet per minute. I'm close. So then I got to worry about, okay, how can I convert the minutes into seconds? And I'm going to do a very similar kind of approach here. We're going to write our ratios again. So 60 seconds is 1 minute, and it's equal to 1. And it's also the same as if I said 1 minute was equivalent to 60 seconds. And again, I want the one with the minutes on the top, so I'm going to use this one on the right. I'm going to multiply 1 minute over 60 seconds. Okay, now this looks kind of like a little bit of a mess. And originally, that's kind of what it does look like. But we can use this to kind of guide our thinking. If we look across the top here, what's really happening is I'm going to take 75 times 5,280 times 1 times 1, technically. So the 1's go away. Cool. And we're going to divide that by, if we look across the bottom, 1 times 1 times 60 times 60. Which, if we do a little simplification, we can say this is the same thing as 396,000 divided by 3,600. And this would be the same as 110 meters, or not meters, feet per second, if we do our division. Now, it's a bit of a lengthy method, but it does really help guide the thinking. I don't know if I would have thought to multiply by 5,280 and then divide by 3,600 right off the top of my head with that, because we're dealing with a rate. So the idea is we're writing our ratios like we did in our very colorful line here, with a series of other ratios to try and essentially cancel out the units. Now, it seems like a lengthy method because I was trying to explain every little step, and there is a little bit of thinking that goes into it, but if you just write your ratios when we're looking at our unit conversion factors, then we can just, okay, which way do I want to write it? Do I want to write it with the feet on the top or the feet on the bottom? And the idea is you're going to look at what you already have to determine what you need. So this is one of those things where the more you do it, the more it'll make sense. So if it didn't make sense on the first viewing, feel free to check out this video as many times as you need. Highly, highly suggest rewinding if there's a little bit of confusion. It might make sense upon another viewing.